I'm Fabian and a freelance web developer from Aachen, Germany. In this talk, I want to present how we utilized Hasura to bootstrap a medical mask listing platform in just 3 days. So when COVID-19 was on the rise in Europe, different countries encountered a shortage of medical masks and other medical protection gear. A lot of companies normally producing other textile products ramped up the production of masks, but didn't have the supply chain in place to distribute them. We decided to build a listing platform to solve those problems by connecting buyers and suppliers of those goods. So I quickly want to give you an overview over our web app. So this is the main landing page telling the rough idea of this app. And so this is the buyer's view. Buyers can discover new suppliers by filtering after product types, and they see prices, lead times, and available capacity of medical masks and other gear. So then buyers can select a supplier, dive deeper into the product portfolio, see product images and the prices and lead times. And then they are able to contact the suppliers, filling out a contact form, attaching what types of products they're interested in, the amount of products they need, and then the contact will be established with just email. And so buyers and suppliers can then negotiate their deals offsite our platform. This is the supplier view. Supplier can input their product portfolio, fill out contact information, and then they will be moderated by one of us and either accepted or rejected to the platform. Those are our current weekly capacities. So all of our suppliers combined offer 650 million medical masks, about 50 million community masks, and other protection gear like face shields, glasses, and surgery gear. This is the team behind our project. So David is holding a PhD in the field of textile supply chains. He was approached by many companies asking him for help in finding customers for large amounts of already produced medical protection gear. And at first he connected buyers and suppliers manually by hand via phone and email. He asked me then if I could build a platform around his initial idea, giving buyers and suppliers the opportunity to negotiate deals without being manually supported by him. And since the demand for such a platform was growing quickly in Europe, I brought my two closest freelance friends, Firat and Arno, on board, and together we developed and launched the entire product after a long weekend. In this talk, I want to quickly go into the architecture of our Hasura setup and also how we scaled and statically optimized everything. So currently, our Hasura backend is hosted in a $5 droplet over at DigitalOcean alongside the Postgres database. The application is a JavaScript single-page application, which is built on Next.js, which is built on React. And we are hosting everything over our friends at Vercel.com, so just the front end. So Next.js out of the box gives you server-side rendering, which is really beneficial for having quick load times and also benefits stuff like SEO. So let's go into scaling now. Actually, there is a short background story behind our scaling efforts. So 2 weeks after launching the platform, we were approached by one of the main television broadcast companies from Germany, and they wanted to feature us in a documentary about COVID-19 and the shortage in supply of masks. The journalist told us that we should expect between 100,000 and 200,000 concurrent users during airtime of the show, and that made us reconsidering our architecture. So at first, we had to do some homework and benchmark the entire setup. So we used Artillery to check how many users our current architecture could sustain. And we quickly found out that the architecture with a $5 droplet could sustain 200 requests a second, which can be extrapolated to around 2,000 concurrent users. And so this is obviously a ballpark away from those 200,000 users we would need to sustain a couple of days from now. So we quickly had to go through our options. So we were thinking about horizontal scaling, vertical scaling, and cachings or like /static optimizing a lot of stuff in our platform. And so let's go over those options. Vertical scaling obviously means that you're just throwing more money on the problem. So we started out with a $5 droplet. You can invest more money over DigitalOcean, buying a bigger server, with more CPU and memory. And so you can scale to ridiculous amounts, to ridiculously big servers over at DigitalOcean. Obviously, this price is a little exaggerated, but so the $40 droplet we also tested with Artillery.io, and that would have gained us 1,500 requests per second and extrapolated to around 15,000 concurrent users, which is still a ballpark away from giving us the 200,000 concurrent users. And 200,000 concurrent users scaling at DigitalOcean would have cost us around $1,000, and you would have needed to chat with the DigitalOcean support in order to set that up. And since the broadcast was in 2 days, that was not a feasible solution. Second idea, horizontal scaling. So in horizontal scaling, you're basically setting up multiple droplets, so multiple servers with the same Hasura setup, and you then distribute the users between those instances. And for that, to make that happen, you need some kind of a load balance entity. You need to pull out the Postgres database as a single managed database. And you also need some kind of monitoring service to see what's happening inside of those droplets. And still, for scaling to 200,000 users, you would need around 100 of those Hasura droplets, which is also not very feasible in monitoring and orchestrating. So this was also not an option to achieve in the short time frame. So let's go into caching and static optimization. There are two ideas behind it. So you can cache just client-side requests, or you could prefetch expensive queries during build time. Let's go into the first idea. So see the feature on the left side again, where buyers can filter for suppliers by ticking the checkboxes of products. And so every permutation of different filters will send another GraphQL query to the Hasura backend, and the Hasura backend will respond with the found data. So you can intercept this query by utilizing Cloudflare workers. So this is the setup. Normally, you would just send a GraphQL query over to Hasura, and Hasura would respond with a JSON response. But then you just intercept this query by adding a Cloudflare worker in between it. And so in the Cloudflare worker, you can calculate a hash based on the bare string of the GraphQL query, then fetch the Hasura response, and then store everything in the key value table. So you take the hash and you save the response, and then you can attach an expiration date to that, let's say 20 minutes. And this way, the Cloudflare worker would respond with the same response for the next 20 minutes, and with that shielding your Hasura instance for a more heavy load. Second idea, prefetching expensive queries. So this is our main landing page, the same stats as I presented earlier. So those numbers don't have to be very accurate. So it's perfectly fine to only update those numbers once or twice a day. And that's perfectly fine. So this would also then shield Hasura for answering with those statistics on every visitor on the main landing page. And you can implement that and take advantage of some features of Next.js. So Next.js offers you some lifecycle methods which are only executed during build time. So one of those methods are getStaticProps. And in getStaticProps, it's just a React lifecycle method inside the Next.js framework. You can trigger a request to the Hasura backend, take the response, and inject this response in a React component, which is then displayed on our landing page. And so getStaticProps only runs during build time. And so only if you publish an update to your platform once or twice a day, this query will bother the Hasura backend. And this way you take off some more load from the Hasura backend. And with utilizing both of those concepts, so caching requests and statically prefetching a lot of expensive queries, we were able to scale our infrastructure to 200,000 concurrent users with just the $5 DigitalOcean droplet, which we felt really cool about. So mission accomplished, so to speak. But unfortunately, we were cut from the program because the executives of the broadcasting company wanted to extend the report on the Queen's birthday. That was pretty unfortunate, so thanks for the ZDF for getting their priorities right. This was literally how we felt when we found out that we were just cut from the program for the Queen. But yeah, still we learned a lot of stuff during the build of this project. So Hasura enables you to quickly prototype a new web app, and with a little tweaks here and there, like caching, you get it to a production-ready state pretty quickly. And caching is also easily possible with GraphQL. So you can just take the raw GraphQL query as a string and cache the response to it, as I presented with Cloudflare workers. And caching is very important in order to save big bucks on your server infrastructure. Prefetching during build time is also a very good idea to get rid of very expensive queries during the visit of new users. And so I want to close this talk with saying a big thank you to all of those entities who helped us And if you are a non-profit in this industry, it's really cool to see how many people are helping you out. So big thanks to DigitalOcean, Vercel, Slack, and Asura for supporting this project. And that's about it. Thanks for your attention. If you have any questions to this talk, feel free to reach out to me. And yeah, enjoy the rest of the conference. Thanks.